Hey guys, welcome to my YouTube channel. I'll be solving LeetCode 75 list using Go. So let's look at today's question, maximum average subarray 1. You're given an integer array nums consisting of n elements and an integer k. Find a consecutive subarray whose length is equal to k that has the maximum average value and return this value. Any answer with a calculation error less than 10 power minus 5 will be accepted. Okay. So let's go back to the drawing board and try to understand the question first. So in this example, we have an array and we are also given a k which is equal to 4. And we want to find a maximum subarray which is of size k that has maximum average. So for example, now consider this window. What is the average of this window? How would you find it? Average of this window would be 1 plus 12 minus 5 minus 6 by 4, correct? And then like that there can be multiple subarrays. This can be one subarray and the average of that will be different, and then another subarray can be this. So for you need to consider each different subarray, find their average like this, and then see which one is maximum. So how do we do this? So whenever we have to find something we do with windows, there is a very popular technique called sliding window. So employing a technique like sliding window will often give you O of n time complexity, and it's one of the easiest way to solve that problem. So every read code problem has some sort of tricks which has to be solved using a pattern, and for this specific problem the trick is to use sliding window. So let's first understand what sliding window is, and then we can see how we can apply this to the problem. Sliding window. So the way sliding window works is we need to have a window of certain size, and then we need to do certain operation on that window. Okay. So basically the way we will do is, sorry, if okay, yeah, if L is equal to 0, and then for R we go from 0 to n, which is the length of the array, and then if R minus L plus 1, which is the size of the window, if it is equal to k, we will do something. Okay, if R minus L plus 1 is equal to k, do something. And if at any point, if the size of window R minus L plus 1, if it exceed k, then increment your L, because the size of the window is no longer equal to k, that's why you increment L. So any of the problem which requires you to do something with window, doing some operation on the window, you use some technique called sliding window, and it usually goes like this, where you sort of find a window and do something with the window, and then if not if you exceed the side of the window, you just increment the L. So this is how you will solve this. Now let's go and see how we will specifically solve this problem. Okay, let me erase this up, and then let's look into this. So how do you find an average of this array? As I mentioned, it will be 1 plus 12 minus 5 minus 6 by 4. And you can also think of this as 1 by 4 plus 12 by 4 minus 5 by 4 minus 6 by 4. So this is just basic arithmetic, just splitting up the fraction. And here you can assume if this is the window, your L will be at the beginning and R will be at the end. So essentially L will be pointing here, R will be pointing here. So whenever you extend the window, I'll use a different color. whenever you extend the window, basically when R goes here, you can just, if you have the running average, so let's call this average. So average value is equal to, if you compute this, that will be the average value. So whenever you extend the window, the size of the window increased. Now it's no longer k because your R is here, the size of the window is no longer k. So in that case, from this average, you can just subtract 1 by 4, which was the old L value, and add the new value, which is 50, 50 by 4. So now what happened? You got the new window, which is this. Let me write it down here, which is 12 minus 5 minus 650. You got the new window. And then have like a global result and see if this average is greater than the previous average, if it is updated. Now again, if you want a new average, what you will do, again just increment your R. You will increment R, and before that you will also decrement wherever your L was pointing. So in this window, 12 minus 5 minus 650, your L was pointing at 12. L was pointing at 12. So you would basically, from whatever average, you would subtract 12 by 4 and add the new R, which in this case is 3. So this is how you will, like, every time you expand the window, add the new R, subtract the old L. That's how you will be solving this. But doing this sort of fraction addition, especially when you're dealing with floating point, can be cumbersome and can also lead to like floating point errors. So that's why instead of dealing with the floating point, let's only consider the sum. So let me erase this. I think it's already very messy, so I'll make it much better. Yeah, so this is our example. So first window is 1, 12 minus 5 minus 6. So instead of finding the average, find sum. 1 plus 12 minus 5 minus 6, and an average is just divided this by k, right? So whatever we did before, we will do the same with sum. So basically your L is pointing here, R is pointing here. Let's use a different color. L is pointing here, R is pointing here. Whenever you expand the window, you just from this sum subtract your L, which is 1, and add the new R, which is 50. Keep doing this and find max sum. And then when you're returning, just return max sum by k. Why this works? Because instead of finding average at every point, you just do it for sum, and then only while returning you do by k, because it's essentially the same. If you most of you who have done math in elementary school, you will just know this, because it doesn't matter. You can, instead of doing average every time, you can just like sort of do it for sum, and while returning you can just like sort of divide by k and find an average and return, which is essentially the same thing. And this particular approach will give you O of n time complexity and O of 1 space complexity, because you're just essentially using two pointers L and R, so you're not consuming any extra space. So, and this problem specifically was made for a pattern like sliding window. So now let's go back to the coding editor and then let's just write down the code. So as I mentioned, first let's find whatever is the sum of the first k elements. I plus plus. So initially your sum will be equal to 0. Sum plus is equal to nums of 5. Now after this, you will also, your res will be equal to sum. So why is it equal to sum? Because till this point the maximum sum is sum, because the first window sum is sum. So till now the maximum is sum, so we initialize res as sum. Now traverse the rest. So k is sorry, not k, I again reinitialize to k. I is less than len of nums and I plus plus. Okay, now as I mentioned, sum will be, sum is equal to sum plus nums of r minus nums of L. So as and when we are incrementing the window size, you're adding nums of R and incrementing nums of L. So what is this error? Oh, okay. What is R in this case? As I mentioned, R is the current whatever you are including, that is R, which is I in this case. What is L? L is nothing but whatever was there whatever was there in the previous window. What will that be? I minus k, which this was the previous L. I minus k was the previous L. So we are basically adding nums of I, decrementing L, which was I minus k. Okay, so if you are getting confused, we can also do this. We can do this. I is nothing but R, L is nothing but I minus k, which was the previous which was in the previous window. So now add R, subtract L, and if this sum at any point becomes greater than res is equal to sum, update it, and then at the end just return okay, float of res by float of k. So why are we doing like this? Because at the end we need to return the average. So I had to do res by k, but in Go you need to make at least one of them float, because we have to return it as float. But why did I make both of them float? Because it's just a good practice in a language, in a strongly typed language like Go. It's a good practice to typecast it. So instead of making just one, I just made two, but you can just make one also, it will work fine. Okay, yeah, accepted beats just 25. That can't be true. I'm not sure. I just, when I did it before, I had 100%. Yeah, the editor is weird sometimes. Now we have 100%. Time is of n because there is just one loop, and space is O of 1 because we are just using 2 pointers essentially. I hope you understood the concept. We have two, we record the size of the window L and R, and whenever the size of the window is equal to the given size like k or something, we do a certain operation. Here whenever it's equal to k, we just find the sum, and if it is greater than res, we just update it. That's what we are doing. And stay tuned, I'll be doing more sliding window questions in the next couple of days. So just stay tuned and please subscribe if you haven't. Thank you so much.